Next up, we're going to provision our Pulsar cluster. Before we do that, we're going to have to create the Pulsar namespace. And then we're going to run kubectl apply, and we're going to feed it into a YAML file that's going to use the StreamNative Private Cloud operator to then provision the Pulsar cluster into the Pulsar namespace. Now, I don't want you to copy and paste this command because this is going to download the Pulsar cluster.yaml file directly from the internet, which is not the one I want to apply for this course. Instead, there's a file that you can download that you should have seen in the previous section that we went through and discussed why it's configured in a certain way. So we're going to go ahead and have you apply that file. Of course, you need to place that file inside of a folder. I've moved into that folder in terminal, and then we're going to put a reference to it in our kubectl apply command. So first, let's create that namespace Pulsar. So here in terminal, I'm going to go ahead and execute the kubectl create ns Pulsar. And then I'm going to do the kubectl apply -f, and I'm going to reference the file that you should use, or you should reference the file that was provided for the course. I'm actually going to check the name of my file. Mine's currently Pulsar cluster custom.yaml. Yours might be slightly different, what you're downloading for the course. So do a kubectl apply f Pulsar cluster custom.yaml. And then each time we want to make changes to our cluster, we're going to edit that YAML file, and we're going to reapply it, and it's going to apply the changes through the operator to our Pulsar cluster. So the operator will know how to apply those changes to that YAML file in a safe way. So when you do the apply f Pulsar cluster custom.yaml, you should see that all of these get created, and we're going to go ahead and wait for a lot of things to start up. There's actually a lot of things that get made through this. Everything that's defined in that YAML file is going to get created. So you're going to get your coordinator, zookeeper, bookkeeper, broker, proxies, and the console are all going to be created. You might see something slightly different than what I have in this list based on if I've decided to edit the YAML as the course has gone on. But to see what actually is now running in that Pulsar namespace, we can do a kubectl get all and Pulsar. The operator is taking care of creating all of these items. It's going to take maybe a good 5 to 10 minutes till everything gets started up. But let me expand my window here so you can see. These are all of your pods that are starting up. This isn't even all of them yet, because not all of our stateful sets are defined yet. But you can see that some things are creating, like Zookeeper, proxies are getting created, services here are getting started up, our stateful sets, again, these aren't even all of them because I don't see brokers here or bookies. So we're going to go ahead and wait a good 5 to 10 minutes, and then we'll check again here, and I'll show you what it should look like after everything gets started up. After waiting just a few more minutes and running kubectl get all and Pulsar, this is what you should see at the end after everything's up and running. We're going to have multiple bookies here that all say 1 out of 1 running. We're going to have multiple brokers running. We're going to have multiple proxies, and we're going to have multiple zookeepers. Later on in the course, we're going to be using Toolset to log in and use some of the tools like Pulsar Admin and Pulsar Perf. These are the services that are running. The main one here is I want to show you that there is by default, a load balancer in place. This is an external IP address. So because we have the network load balancer pre-installed for you in our Kubernetes environment, our AWS environment, the private cloud operators are automatically going to create that external proxy and get an external IP address to the internet. Now, this is not secured. This is on port 6650 at this location and not secured at all right now. If it was secured, a secure endpoint for Pulsar would be on port 6651. So this is on port 6650. And then the admin endpoint is 8080. Which is also the unsecured admin endpoint. Our stateful sets here are basically just saying out of the 2 requested proxies, we have 2 out of the requested brokers, we have 3 out of 3, things like that. So we're going to be working a lot more in the course, looking, oftentimes changing things in the YAML file, looking to see that they're changed here. We're going to be killing some of the pods and showing that they automatically get brought back up. But basically, what you need to know here is that these pods are running on those 8 EC2 T3 medium instances. This external IP was created because we had the network load balancer for AWS. When these services like Bookkeeper or Zookeeper come up, they have PVCs or persistent volume claims that come up, or requests for storage. Because we've already installed the EBS driver for AWS, it's going to know to give us some disk space inside of EC2 to satisfy those persistent volume claims. So then we're going to successfully be able to get our bookies to come up and our Zookeeper to come up.